Hello, can you hear me?
Yes.
All right. Today we're going to round up the class, and tomorrow morning I will make your final exam available so you can take it anytime from tomorrow to Monday. So the final exam will be taken in Canvas. Give me 1 minute. Let me pull this out. Let me pull this out. Pull this out. Open this. Um, Georgie.
Good afternoon.
How are you today?
Wonderful.
Just give me a minute. Let me put this in. Okay, good. Excellent. This is your class right here. So, but by this weekend, I will have everything graded. And in fact, like I said, the final exam, I will show you where to. I have already shown you in the class, but I'm going to show you again after we finish where to get it. Look at the final exam, and it will be ready tomorrow. I'll put this available for you tomorrow. Okay, let's see. Tonight, we'll be rounding up. Let me share my screen with you. What is this? I'm about to close some pages. Close this page. Okay. All right. I think we are ready. So tonight we'll be working on correlation and regression. Correlation and regression. So most of the work we'll be doing on Excel, so it won't take us long. Correlation simply means a way of finding out the extent to which two or more variables move together or are related, so we use correlation to find that. And then regression, we use regression to determine the strength of that relationship between one variable and the other variable, So things like we have a business might want to know whether the volume of sales they receive is based on advertisement, that they did, or maybe an educator might want to know if the number of hours students spent in their studies can affect their grades, or maybe boost the grades, or make it make the student receive a higher grade. So there are many things where you can use it, or things like blood pressure and age, diet and weight, vaccine and disease prevention, things like that. That's why we use correlation and regression analysis. Now, when we talk about the variables, there are two types of variable we're referring to. The first one is the dependent variable. This one is the one that we can control. Sorry, that we cannot control. So we cannot control it, we cannot manipulate it. Example, things like cells. You cannot control the amount of cell you receive, but you can say, I'm going to spend $1,000 in advertisements. Well, you can do that, but you cannot control how much sales you get from that by that advertisement. The same thing with hours of study. You can say, okay, I want to pass this class, I want to have an A. Yes, okay, you spend so much hours studying, but you cannot determine if your A will be 91 or 92 or 95 or 97. You have no control over that. Or if your score will be 85. No doubt, if you put effort, you can boost your score, but to what extent, you have no control over that. And so on and so forth. So we call them the dependent variable or the response variable. Mathematically, we use y to represent the dependent variable. The independent variable you can control. You can manipulate it, you can control it. Example, advertisement expenses. You can decide to spend $1,000 in advertisement, or you can decide to exercise only for 1 hour in a day. See, you can do that. You can decide to eat twice a day. But you can, if you decide to exercise only for an hour a day, you have no control over how much health benefit you get from that. Yes, you get health benefit from there, but you don't know how much. You can't control that one. But you can control the number of time you spend doing exercise. Excuse me. So these are the two variables. So we call it the predictor variable, or the independent variable, or the X variable. Now, for correlation coefficient, we use rho. This symbol, we call it rho. It means a way of measuring the degree to which the two variables move together. So there are many types of correlation coefficients, but the one we'll be using for this class is what we call Pearson product moment correlation coefficient. Pearson product moment correlation coefficient, and we represent it with rho for the population correlation coefficient. We use this symbol rho to represent it and make it bigger. Make it 18. But nobody knows what this value is because it's for the population. So we use R, the sample correlation coefficient. This is the rho is for the population. Correlation coefficient. See? But the smaller one for the sample, we use R to estimate it, which leads us to the range of values for the correlation coefficient. The range of values for R, it goes from -1 to +1. You can see right here, -1 to +1. If there is no relationship, it will have a correlation of 0. Or if the relationship is very small, very little, very weak, it might have 0.15, 0.2. Now, for the positive correlation, as you go to the right side, the value increases. For example, education and good job. See, they correlate. You can see the value goes up. More education, better job. So one of them increases the other. But for the negative correlation, they go, contrary to each other. For example, the higher the speed, less time. See, they go opposite each other. But for positive correlation, they go in the same way. So the whole of this all is a lie. So for this, so long as they approach the -1, if the answer approaches -1, for example, let's say the answer is -0.85, it shows a strong negative linear relationship. And if it approaches 0, it's a weak negative linear relationship. Then for the positive one, same thing. If it approaches then +1, the strength of the relationship gets stronger. Okay, and so on and so forth. I'll give you another example. I think I mentioned speed and time for negative correlation. I think that's a good example. Now, how about relationship between advertisement and sales? They are positively correlated because the more you advertise, the more you attract, customers. But how about something like pesticides? Okay, pesticide and weed. The more pesticide you apply, the less the more herbicide you apply, the less the volume of the weeds. See? Now, you can see the different variations where when it is 0 to 0.2, the strength of the relationship becomes very low. From 0.2 to 0.4, it is low. From 0.4 to 0.6 is moderate. 0.6 to 0.8 is, highly moderate. and so on and so forth. So now, things like hours you spend studying and your grade, we expect things like that to be highly positively correlated. So you can assign the value of 0.6 to 0.8 to that, and so on. Now, another one we use to show relationship between two variables is what we call a scatter plot. A scatter plot is a visual way of describing the natural relationship between the dependent variable and independent variable. Now, look at this one here. If this is see, if you look, these are the x and these are the y. If you plot all the numbers you have, if you get something like that look like this, you can see that it is trending up. So it indicates a strong positive linear relationship. Hold on, I think I made it too much. You can see right here, strong positive linear relationship between x and y. That means as x increases, y also increases. If it is trending down, like this one here, it indicates a strong positive. Why is it not getting big? Let me see. Make sure it's negative linear relationship, because this one is trending down. So for this one, when s increases, y increases. So it's a positive linear relationship. A good example includes the age and blood pressure. As your age increases, your blood pressure increases. That's one example. Another example is advertisement and sales. More advertisement, more sales. So increase in advertisement, increase in sales. But for this one, it's the opposite. When S increases, Y decreases. See, if when S is 300, see that Y is about negative 2.5. When S is 400, it's about this is an inverted scale. This is an inverted scale. Yeah, because you need to start from -1 here, all the way up. So I'm gonna change this, but one thing is here. I'm gonna erase this side. So main thing is the trending. You can see the trending. As S increases, you can see that S increases. You can see Y decreasing. As soon as this side is for increasing Y, so as S is going down, if S is going backward, that's back down to 200. See, Y goes up. When S increases, Y goes down. So now, example: speed and time. The higher the speed, the lesser the time. So if you look at this one, it doesn't show any trend. So this means there is no relationship between X and Y. See, there's no linear relationship between X and Y. It doesn't show any pattern or trend. See, no relationship. Example is this: the rate of inflation in the United States and birth rates in California. They will not relate. They're not related. So it will give you a scatter trend like this, scatter plot like this one. So no relationship. Now, we can now look at some things that some common terms we use when we do regression and correlation. One is I've already mentioned the correlation coefficient that we use R to present sample correlation coefficient, and I have explained what the dependent variable and the dependent variable or Y variable and independent variables means. Now let's look at more terms. We have coefficient of determination. This one tells us how much of a variability of a factor that can be cost or explained by relationship with another factor. Don't worry, when we do an example, I'll use an example to explain it more. Then we try to predict, to develop a model using the regression equation. So that equation measures the extent to which researchers can predict one variable from the other. So it helps us to predict one variable for the other, especially the dependent variable. So this is for this class, we're doing only the simple one, simple correlation coefficient, which is y equals BO plus B1x, where BO represents the y-intercept, if you remember from your algebra class, and B1 is the slope. Now, this slope means rate of change, really, here. Now, computational formulas we use, these are the formulas we use. These formulas, by the time you use this, they ask you to calculate the correlation coefficient and get this, derive the regression equation using the given data. It might take you up to an hour to finish this. So, but we're not going to be using these equations. We'll be using Excel so that it will be done in a very few minutes. Now, this is another equation, another formula. Remember, I mentioned in a class that statistics might have two different formulas for the same thing. Now, if you're using this approach, this is the formula for the correlation coefficient. If you're using this method, different method, this is the formula. So again, we'll be using Excel. So not the formula at this time. So I just you still need to know about them, that they exist, they do exist. In case you find yourself in a place that does not have electricity or a computer, you can use the formulas. Anyway, I think you get the point. Let's try one example here. It says here, in a random sample of 9 steers. Steer is a type of meat. I think it's a type of beef or something. Steer. Let's see. Steer. Let us see what it actually means. I'm sure it is a type of meat. We'll see in a minute. Let's see. Okay, I think I'm going to use this. Okay. A steer. Because I use Google. Okay, steer. Okay, meaning. Okay.
Isn't it cattle?
It is a type of beef. Beef meat. Steer should be meat. Yeah. Just give us all the definitions. Steer. Okay, as a meat. Okay. A meat. Okay. Let's try meat. Yeah, see? A steer is a young bullock. Yeah, young cattle. See? You can see the diagram here. A steer. All right, so I think you get it. So in a random sample of 9 steers, the live weight and the dressed weight are recorded. You know, when they kill the cattle, they do the boning. They remove the bones and some parts, so they call it boning. And after they finish that, they now dress it and package it for sale. You can see that the live weight will be different from this dressed weight. So the live weight and dressed weight were recorded. In the table below, we let Y represent the dressed weight. And all these are in pounds, in hundreds of pounds. And X denote the corresponding live weight. So this 4.2 means 420 pounds. 3.8 means 380 pounds. You know, the same thing with here. 2.8 means 280 pounds. Now the question says, construct a scatter plot for this data. Use the sample data to obtain the least square estimate of the regression equation. That means it says find the regression equation using the least square method. Then it says calculate the correlation coefficient R and compute the value of R squared and explain your result. What is the predicted dress weight when the live weight is 700 pounds? Is there a relationship between the live weight and the dressed weight? Okay, you ready? Let's do it.
Oh, that's a lot to do.
Yeah, but as Excel, you see, without Excel, it takes you more than an hour to finish this. Yeah, but with Excel, it takes you a few minutes. So first thing is to put this data in Excel. So I'm gonna copy it, or if you like, you can type it in. Um, Type it in or copy it. Copy it, make it faster for you. Where's our Excel? Excel's right here, and then paste it here. So this is the live weight, and this is the dress weight. Live weight. Type live weight. And the other one is the dress weight. Okay. I can make this let me make it all right, I'm sure you can see this. Okay. All right, live weight and dress weight. We have it. Now, dress weight is the Y variable. Now, next thing is to put this in into the analysis to do the regression analysis, and then the result you get, you use those results to answer those questions they have. So that's what we're gonna do. Is this excuse me, I think I move it so quick. Move on this side. So what I'm gonna do is making sure you have this. Okay. So what I will do is now is to have data. Click on data. Like I see here, data analysis 2-pack on this side. If you don't have it on your computer, you have to put it in by yourself in your Excel. How do we do that? You click on File, click on Options. Okay. You can see what you have. Add-ins. Click on that, and click on Go. Once you click on Go, it will bring this box. Then you check these two things. Once you check them and click OK. Now, we go back again to data. You will see that the data analysis 2-pack will be showing on this side. Okay. So when you click on this, we are doing a regression, right? So you move down to where we have regression. Right here. You can see my cursor, right?
Yes.
You click on that. Click OK. Now for the Y range is your dressed weight. So you copy everything there, including the name, dressed weight. Click inside here. And for your X range is your live weight. So you click here and click everything, including name. Okay. Now, since you included the names when you're clicking on this, so you gotta check on labels. And for the confidence level, they say use alpha 0.099%. They say use, okay, 99. I think 99. For output range is where you want it to be to give you the result, to present the result. So I'm gonna choose it under the question right here. Okay, that's the output. Now, more things we need to put is the residual, and it asks us to draw the scatter plot, right?
Mm-hmm.
So we need a scatter plot. So that is the line of fit plot. That's the scatter plot. I think we have everything we need. Yeah, that we have everything we need. Then you click OK. OK. Are we doing a test? Yeah, it asks us to find the is there a relationship between the two variables? So we have the confidence level is okay. It's good, excellent. Okay. So you give us the scatter plot is here. That was the first question. If you look at our first question, it says here, okay, it says construct a scatter plot, right? You can see that, right? You all can see this.
Mm-hmm. Yes.
So just the scatter plot will be solution. We have it already. Excel gave us the scatter plot. Okay, so I'm gonna go and copy it from Excel. Okay, this is the scatter plot right here. Life width and breast width. Copy this. Go to our Word document and paste it. Okay, we answer the question. Okay, if you like, you can make it to look bigger. Okay, all right. You went to the next page. Anyway, I'm gonna move this so you can have more room for this. Okay. So you go to the next page. You can see that show the trend. See, the higher the this indicates interpretation. The scatter plots indicates a strong positive linear relationship between the life weight and the breast weight. I'm going to email you this video so that you will still watch it. Okay.
Okay.
I'm going to email it. So that's so you can see the trend is trending up. See, yeah, and that answered that question. If you are drawing this on paper, you know how long it can take you to draw the line, make it straight, draw this one, and then start to put numbers in. Okay. Now, next question. Next question is this. It says use the sample data to obtain the least square estimate for the regression equation. That is find the regression equation using the least square method. There are two ways you can do this. Generally, the regression equation, the general form of the regression equation is solution is y equals b0 plus b1x. In this case, y is the breast width and s is the life width. Okay, and that's so you need to find the value that represents BO and B1. BO is the intercept and B1 is the slope. So we can get that from the result in Excel. BO equals, okay, and B1 equals, so you can get those things from Excel result. Let's start with B1. Now, sorry, B0. If you go to Excel, our B0 is, there are two ways you can get it. Like I said, this is our B0 right here. I'll highlight it. Let me make it a little bit bigger. Okay. See, B right here. This is B1. You can see life width. I'll make it slight green. See, that's B1. So this is 0.09. I mean, if you make it 2 decimal places, you want to make it 2 decimal places. Let me round it to 2 decimal places. See? Or three, I think 3 decimal places is good. 0.08, B1 is B0 for 0.086. Let me write them down so that I can just go there and type them in. B0 equals 0.086. B1, now if the, B1 is 0.616. Now, if the question says to make it 2 decimal place, then you make it 2 decimal place. If you say 1 decimal place, make it 1 decimal place. So I take it and write B1. B1 will be, and B0 is 0. Okay, 0.086. Okay, and B1 is 0.616. Okay, so that the regression equation, okay, the regression equation is y equals 0. Use that for B0 here, right? 0.086 plus for B1 you have 0.616 Let's see what it means, what interpretation means. Interpretation of this. So now, so this is the regression equation right here. You can see that. I may highlight it. See? So instead of giving you all the answers. So this means this slope is positive. Say it's positive, right? That means it should an increase. Now, so this means the slope of 0.616 means, because it's positive, if it's negative it means decrease, positive means increase. So it means that the dressed weight increases over time at the rate of, remember all these are in hundreds, so this will be 61.6 pounds. 61.6 pounds for each 100-pound, or when 100-pound increase in the life weight. So when the life weight increases by 100 pounds, the dress weight increases by 61.6 pounds. That's what it means. See? Remember, the slope is the rate of change. Any question before we go to the next one? Any question? Excellent. Now, we have how many questions left? We have 1, 2, 3, 4. Four more questions left, and we'll be finished the work for tonight. So, and I will give you try to practice it. So, but we have only 6 minutes left. That will not be enough for us to finish this. So I recommend them. I'm gonna time us out now, and then you'll log back in next 10 minutes. But before, don't go out yet, because I want to take your names. Let me take your names, then we can now log out. 1 minute. So I got Michelle Spears. I got Walls. So Walls. I got who's Brenna iPhone? Who's Brenna iPhone? Brenna iPhone, who are you? I got Martin Jasmine.
Yes, I'm here.
Then I got Kenisha who? Okay. I got White. I got Olubumi.
Professor, you saying Nicole White or?
Yeah, I called you Nicole. I got your name.
Okay.
Taylor K. Is it Taylor? Taylor K, right? Kelly. Oh, Kelly. It's Kelly. Smith.
Professor, did you get mine?
Wait, is it? Are you Wilkins?
No, I'm Sarah Naiga.
What's the last name again?
Naiga. Naiga.
Okay, are you the one with? Oh yeah,
iPhone.
iPhone. Okay, I think I got everybody. So please log back in after 10 minutes. Okay, let's round up. Okay.
You said 10 minutes?
Yeah.
All right.
All right. See you then.